Hello, Eric. Got your book. So I heard you're doing 6.8 today, operations with scientific notation. I'm going to, in the examples, use easier numbers rather than these tough numbers are given here. I'm just going to use easy numbers when we go to check for understanding. But first, a word from our sponsor. I want to do show you a think, Bob, and it's going to be with proportions. And I'll ask you again, what's a proportion? And can answer it. Anyways, it's when a ratio equals a ratio or a fraction equals a fraction, but I want you to have a much richer understanding of it. And so I want you to be able to words, table, equation, graph, all right? So anyways, it'll be, when it's a line, it's a line that goes through the origin. And when it's a table, you'll see, anyways, Bob has no money and he saves $2 each day. And so here's my X, Y, and it's always gonna be Bob, and it's always gonna be days and dollars. X will be days and Y will be dollars. And anyways, and so Bob starts with nothing. So it's 0, 0, which means it's gonna go through the origin. And after one day, he's gonna have $2. He's going up $2 each one day, right? After 2 days, he's gonna have $4. Again, it's a constant rate of change. He's going up $2 every day, which is your, you can find your rate of change from the table. This is up 1, and this is increasing 2. Or if I wrote it like this would be $2 every one day. It's this is your change in Y, and this is your change in X. This is your change in Y, this is your change in X. That's how they're related. Which is your K. K is your rate of change, your constant rate of change, which is 2 over 1, which is just 2. Y equals 2X. And this is also your slope, which I'll talk about later. And then B is your y-intercept, but since you're starting with nothing, your y-intercept's always going to be 0 here, so it's plus 0, so we just y equals 2x. And if I go to graph this, these are just by 1, so over 1 up 2, over 2 up 4, and here's my line, and here's my slope, my rate of change. It's going over 1 up 2. And it's rise over run. It's 2 over 1. Every time I go over 1 day, I go up $2. But there's thinking Bob. First time, just showing you it. Next lesson, I'll start you with words and see if you can produce the other 3. All right, but Bob has nothing. Bob has nothing. Bob has nothing plus 0. I could say plus 0, but you don't need it, so it's just y equals 2x, and Bob has nothing. And he's saving $2 a day, he's saving $2 a day, he's saving $2 a day, he's saving $2 every day. All right, so now, let's get into your lesson here. So here they show you when you're adding, and if the exponents are the same, you just add the numbers in front and the exponents don't change. And then since this is more than 10, or 10 or more, you have to rewrite that because this number has to be less than 10. So it's just 1 times 10 to the first. We'll put a 1 there. And 1 plus 5 is 6. So you always want to correct scientific notation, right? And then subtracting, same thing. If the exponents are the same, you just subtract, and you get 2.7 times 10 to the 7th, right? So friendly. Rather than doing these, let's just do. How about a friendly one here? How about 5 times 10 to the 8th plus 3.1 times 10 to the 8th. Go ahead and do that. What are you going to get? And you're just going to add those. You're going to get 8.1 times 10 to the 8th. right? So that's adding and subtracting, right? When the exponents are the same, right? Oh, so remember scientific notation, the first number is between 1 and 10, or greater than 1 and less than 10, times 10 to the, and then you have an integer here. When it's positive, that means it's a big number. And if that's negative, that means it's a small number, right? So what happens when they're not, the exponents aren't the same? And here they show you two ways to do this. And really what you want to, you want to do it this way. You want to change it to where they're all 10 to the fifth. You always want to go to the biggest exponent. And so 5 is bigger than 3. And when you have negatives, you'll want to go, the biggest number is the smallest negative. I mean, anyways, the number on the right, this is bigger than that. So anyways, and so when we change, we want this to be 10 to the fifth. So if we move this over 2 to the left, that's times 10 to the second. And when we multiply 10 to the second times 10 to the third, you get 10 to the fifth. So it's kind of, anyways, just show your work, you'll see it. And now you can add, and you should be able to add in your head, this is 5.172 times 10 to the fifth, right? So this way is better, right? So let's just make up one example here. What if you had 6.1 times 10 to the 7th plus 2 times 10 to the 6th, right? So say you had that. Well, which one, do you want to make them both 10 to 6th or 10 to 7th? Well, by what I said, you want to make them 10 to the 7th, so this one has to change. So this is 0.2 times 10 to the 1st times 10 to the 6th, and then you can, so that's going to be 0.2 times 10 to the 7th, and now you can add, and you get 6.3 times 10 to the 7th. So that's the idea there, all right? And then and boy, they must let you use calculator because you got a lot of multiplying here. And then when you multiply, you just multiply the numbers in front, and then you add the exponents. So 3 times 4 is 12. Let's just times 10 to the 7th, which would be 1.2 times 10 to the 8th if we just rounded and did easier numbers there, all right? And dividing, you just divide them, and then you subtract. When you're dividing, you subtract. 8 minus 5 is 3. So when you multiply, you add your exponents. When you're dividing, you subtract your exponents, right? And then when you have negatives, it gets even squirrelier. Dividing, well, that divided by that's just going to be 3. And when it's negative 6 minus negative 2, which becomes negative 6 plus 2, which would be negative 4, all right? And so 1 billionth of a meter is written that way, or 1 times 10 to the negative 9, right? Oh wait, it is 40 nanometers, wait. The wavelength of violet is visible 40 nanometers is 1 billionth. So you're just multiplying that by 400. So that's 4 times. And when you multiply, you add, so you get that. There you go. All right, so let's do, just how about an easy multiply one? 4 times 10 to the 3rd times 2 times 10 to the 5th. You're going to get 8 times 10 to the 8th, right? And dividing 6 times 10 to the negative 7th divided by 2 times 10 to the, how about negative 4? 6 divided by 2 is 3 times 10 to the, and negative 7 minus negative 4 becomes plus. Anyways, you get negative 3. All right. And when you get a number that's not between 1 and 10, then you have to change it. Say the answer was 0.14 times 10 to the negative 7. Well, you want that to be 1.4 times 10. This is a small number, so that would be 10 to the negative 1. That would move it over, times 10 to the negative 7. So that'd be 1.4 times 10 to the negative 8. Right? Or if you had, what if you had 230 was your answer, times 10 to the negative 6. Well, this is 2.3 times 10 to the second times 10 to the negative 6. And 2 plus negative 6 would be negative 4. So that'd just be 2.3 times 10 to the negative 4. All right. So hopefully that helps. I'm going to stop there.